This is Brian Putt. Today I'd like to talk about the multivariate normal distributions using SIPmath. Sometimes these are described as correlated normal distributions. We will set up three normal distributions that are multivariate or correlated amongst them. Here is a blank spreadsheet. We were going to start by initializing the SIPmath modeler tools. So we'll initialize to 1,000 iterations. And now I need to define my normal distributions. We'll call them normal 1 and normal 1 to 3. We need to define their means. So we'll put those down as 2, 3, 4 maybe. And then we need to define the covariance matrix. Let me point out that this is a covariance matrix and not a correlation matrix. Let's start by making them all the same variances. So 4, 4, and 4. Now what is the covariance between normal 1 and normal 2? Why don't we make that 1.5, and we'll make this 1.5, and this 1.5. And so now we want to generate the random variables. So we'll put the random variables here. Random variables, normal. And we're going to need in our definition a random cell. So we'll just put random, I'll do it like this, and then we're going to point to these three. We're now ready to establish the random variable normal distributions. Come up here to generate input, and it's correlated distributions, normal, and the distributions, actually are these three. I might have highlighted those together before, with means of these three values. And the covariance matrix. Covariance matrix is defined by this. It does not have to be totally complete. We just need the lower half of the matrix. And then the random cells, we said we're going to put right here. We'll just use the HDR, and that gives us our three answers. We now need some output names. Let's define them as D underscore norm 1 and D underscore norm 2 and 3. All right? This D stands for a distribution. So now I'll highlight these, define outputs. The output names are shown here. And we will insert spark lines, and we'll say OK. This is the warning message you'll receive if your output name includes blanks. SIPmath will replace the blanks with underscores. It's just a warning, it's not an error. And we now have these variables. We can expand those spark lines. And we can check these and get rid of some decimals. Make them look prettier. And we can also make this a little bit wider. So what we see here now is we have correlated normal distributions. Right? Maybe we don't have them. We just have some normal distributions. Are they correlated? So let's generate some graphics here showing the relationship between normal 1 and normal 2. The results of our random variables is shown over here on the PM table. Norm 1, norm 2, and norm 3. And we have 1,000 iterations. And I have added plots showing the relationship of normal 1 versus 2, 2 versus 3, and 1 versus 3. Let me take those and copy them over to my model over here so we have them available. because what I'd like to show you is we can change these numbers and get different distributions. Let's change these all to 4. So I put a 4 here, a 4 here, and a 4 here. And what I find is that if the variances and the covariances are all equal to the same, they are perfectly correlated and we get straight lines. If we have other numbers in here, then we get different distributions. I could put in a 1, 1, 2, for example. And now we're going to see different correlations. So that's how to set up multivariate normal distributions. And you can set this up for any size array that you want to. Thank you.